So here we've got the at the cut-off saw, or where they chop the logs up before they cut them to length before they bring them in the mill. So this is for all the controls, and these are all the latest VFDs from ABB. These are all Ethernet controlled drives. There's quite a few of them here. This is something new I haven't seen, but the latest keypads are Bluetooth enabled, so we can program remotely with these, or we can program with the manufacturer's software over the network. So I can connect my laptop directly to the keypad and then communicate through its communication cable to the drive. So you can see here again, they've got a really good standard in this mill. They've got an input reactor to all the drives, and they've got, looks like they've got output reactors as well. Well, maybe this side they've just got the input reactors. Input reactor, that'll prevent a massive spike in current on a short circuit. It's just like I like to call it like a choke. And they do have a disconnect. So the master control power, it's got a disconnect and also a line contactor that will kill all the power to this whole assembly. So that's good, so the fans aren't running on the weekend, and also if it senses, you can also do it if it senses a high temperature on something, you can kill the power. And looks like here are all the brake resistors. So this is quite a big system, one of the bigger ones I've seen. These are the brake resistors for all these drives. You can see they're all numbered. They're all labeled. We have to know which one's going to which. We have to confirm it all. Here's one of their spare MCC buckets. It's looks like they've standardized on Allen Bradley motor control centers, and this is a module system, so this would plug right into any MCC 2000 series. So that's got a lot of brake resistors for all these drives. You can see very nice installation, very nice workmanship. And here's the MCCs. Everything's numbered. So they have they'll have an alpha numeric numbering system. W. What does the W stand for? Yeah, this is MCCW, but sometimes that means something to the plant. But it's MCCW, and then they each have a unique number, and that number is going to be painted on each of the drives. So if you go to work on something, you can see what drive number it is, and then you can find MCCW, and then you can lock out the appropriate drive. That's soft start?
Yeah.
So here's an Eaton 100. Look how small this one is. That's a 100 horsepower soft start. It's got a little LCD display. Shows us all the line currents. It's running right now. It's got a so that's just the power supply. One thing about small, physically small, high horsepower drives is they have what's called a bypass contactor inside. So the SCRs are only conducting on startup, and then a bypass contactor closes. So the advantage of that, it allows the size of the soft start to be able to fit in a standard MCC bucket. So that's very important because it just keeps the costs. We might already have these MCCs, but we can just upgrade the starters. This probably had could have had a size 4 starter in it before, which would start 100 horsepower. And there's the terminal strip. That's a 24 volt power supply. This needs a pretty good sized power supply because the bypass contactor operates on 24 volts. And there's the The fuses, those are time delay HAT 150s, and those have the little smart spot. So you can see if you can actually look inside there to see if the fuse is blown. Really nice, nice feature.